In the last video, we looked at word problems that could be solved using single linear equations. We also looked mostly at equations that were in slope-intercept form. In this video, we're going to talk about problems that can be solved using a linear system of equations, and we'll focus more on the standard form of the linear equation. So to remind you, standard form is ax plus by equals c. And here the variables are x and y, and a, b, and c would take on specific values depending on the problem. So we might have something like 30x, maybe we even have a negative, minus 50y equals 60.2. Alright, so let's look at a few examples. We'll start with writing a single linear equation in standard form, and then we'll move to systems. So here's the first example. Suppose you have $15 that you plan to spend on a homemade trail mix. Peanuts cost $3 per pound, and M&Ms cost $2 per pound. Write an equation which represents the possible amounts of peanuts and M&Ms you could purchase. Okay, so similar to the other examples we've done, we have two things that we need to describe in the equation. We have peanuts and M&Ms. So first step is identifying the variables. Alright, so what do we want x and y to represent? Now in the last video, the examples we looked at had that phrase in terms of, so we had something described in terms of something else, and that clued us in as to which variable was x and which was y. In this problem we don't have any clue, and there's not really any sort of dependent relationship between peanuts and M&Ms. One doesn't really depend on the other any more than vice versa. So in this case it's up to you, but those are the two things that we don't know. We want to describe possible amounts, so those are the two things that are the variables. So I'll just go in order of the way that these are written in the sentence. So let's have x be the peanuts, and I want to go back and look for units as well. So this is a cost per pound of peanuts. So let's let x represent the pounds of peanuts rather than just peanuts. And then similarly, let's have y be the pounds of M&Ms. Okay, so how do we write an equation to describe these amounts? Well, we have a clue with the numbers that are given in the first sentence. We know that we have $15 to spend, and let's assume that we're going to spend exactly that. And we know that peanuts are $3 per pound and M&Ms are $2 per pound. So let's think about some possible pairings of peanuts and M&Ms. So let's do the same trick we did before. Think about pairs of x's and y's. Now this one, let's go with some intercepts. So let's think about how many peanuts and M&Ms we could purchase if the other thing wasn't purchased. All right, so if we don't buy any M&Ms, for example, then how many pounds of peanuts can we purchase? Well, we have $15, and we know that peanuts are $3 per pound, so that would mean 15 divided by 3, we could purchase 5 pounds of peanuts. Right? And then what about if we don't purchase any peanuts? How many M&Ms can be purchased? Well, we have $15. M&Ms are $2 per pound. So 15 divided by 2 would mean we could purchase 7.5 pounds of M&Ms. And you could play around with some other combinations as well. So you may notice, like if you purchase, let's say maybe 6 pounds of M&Ms. All right, well that would be 6 pounds at $2 a pound, so that would be $12. And then that would leave us with $3 left that we could put towards peanuts. And peanuts are $3 a pound, so that would give us just enough to purchase 1 pound of peanuts. Alright, so once you have some values here for x and y, we can do the same trick and try to write an equation by finding the slope and the y-intercept. All right, so slope, I need to choose a couple of these points to work with. So I'm going to go with the ones that don't have the decimal. So I'm going to use the points 5, 0, and 1, 6. All right, so subtracting the y values, I would have 6 minus 0, and subtracting the x values in the same order, I would have 1 minus 5. Okay, so the slope would be 6 over negative 4, and I'm going to put that in lowest terms, so that would be negative 3/2. All right, how about the y-intercept? Well, if you did go with this point, if you thought about how many M&Ms could be purchased if no peanuts were, then that would give you the y-intercept. Or you could try to solve for that by plugging another point into the equation. All right, so let me review both methods. We know the y-intercept, so I could jump right to the equation, or I could start with y equals mx plus b, and I know m. And to solve for b, I could substitute an x and a y and solve to figure out b. Okay, so I'm going to substitute the point 5, 0. So I'm going to put 0 in for y and 5 in for x and solve for b. Okay, so this would give me 0 equals, and then negative 3/2 times 5 would be negative 15 over 2. All right, and then to solve for b, I would add 15/2 to both sides of the equation. And then 15/2 is just 7.5. So either way you do this, you will get to that y-intercept. All right, so let's write our equation now in slope-intercept form. Y equals negative 3/2 x plus, and I'm going to write this as 15 over 2 instead of 7.5, and you'll see why in a minute. Because the next thing I want to do is rewrite this in standard form. Right? So the first thing I'm going to do, right, I'm trying to get this to look like ax plus by equals c. Right? And I also don't want any fractions. That's part of standard form. So the two things I need to do, I need to get rid of the fractions, and I also need to get the x and y on the same side of the equation. All right, so I'm going to clear the fractions first, and I see that I have denominators of 2, so I'm going to multiply everything by 2. So this would give me 2y equals, and then 2 times negative 3/2, the 2's will cancel, so that leaves negative 3x. And then 2 times 15/2, same thing, the 2's will cancel, and that leaves me with 15. Then finally I want x on the same side as the y, so I'm going to add 3x to both sides of the equation. All right, so standard form would be 3x, let me write this a little lower, 3x plus 2y equals 15. All right, so why did I go to all this trouble? I had a perfectly good equation in slope-intercept form. Why do we need standard form? Well, I wanted to show you the connection between this problem, the information that was given, and standard form. Right? So notice if you look at the slope-intercept form, we don't see any of the given numbers. There's some, they're in there somewhere, but we don't just have a 15 by itself, or a 3 or a 2. However, we see all of those numbers in the standard form equation. Okay, we have 3x plus 2y is 15. So often it turns out when you have a situation like this where you have a total cost, $15, that's a combination of the costs of two different things, you can really see that better reflected if you write the equation in standard form. All right? So here we have the 3 is the cost per pound of peanuts, cost per pound, and then we're multiplying it by the number of pounds of peanuts, okay, because x is pounds of peanuts, so its units are pounds. Then I'm adding to that the cost per pound of M&Ms times the number of pounds of M&Ms, and then I have that equal to a cost. Right? So think about if you had some specific numbers for x and y. Like let's say you purchased 5 pounds of peanuts, and let's say you purchased 6 pounds of M&Ms. Okay, well, how would you find the total cost? Well, you would do 5 pounds of peanuts times $3 per pound, so that would cost $15. And then the cost for the M&Ms would be $2 per pound times the 6 pounds of peanuts. Okay, so that would be $12. And then to get the total cost, you would add those two together to get a total cost of $27. All right. So if you look at the arithmetic that we did just there, it's the exact same as this equation, except instead of guessing ahead of time the pounds of peanuts and M&Ms, I've just replaced these with an x and a y because I don't know how many pounds of each were purchased. All right. So eventually, it would probably be convenient if we could learn to jump straight from this first information to standard form, right? And you can sort of bypass that chart that gives you the total or the possibilities for x and y. All right, let's look at another one. A 5-pound bag of potatoes contains a mix of red and Yukon Gold potatoes. Write an equation which describes the possible amounts in pounds of the two types of potatoes. So again, step one, we need to figure out what the variables are. Right? So I want to describe the amounts in pounds of the two types of potatoes. And again, neither one really depends on the other. There's no instruction to write one in terms of the other. So I'm free to choose either to be x and either to be y. So I'm going to have x represent the pounds of red potatoes, and then y represent the pounds of Yukon Gold potatoes. Okay, so let's think about some possible values. So let's say that I purchase 2 pounds of red potatoes. Then how many pounds of Yukon Gold are purchased? Well, it's a 5-pound bag of potatoes, so if 2 pounds are red, then 3 would be Yukon Gold. If there are 4 pounds of red, then there would be 1 pound of Yukon Gold. Or if it's not really a mix at all, if there are 0 pounds of red, then all 5 pounds would be Yukon Gold. Okay, so looking at the points here, okay, if we use the 0.23 and 4,1 to find slope, we would have slope is, let's do, right, subtract the y's, so 1 minus 3, and then subtract the x's in the same order, so 4 minus 2. And then slope would be negative 2 over positive 2, which would be negative 1. And then I've already found the y-intercept. I found y when x is 0, so that tells me that b is 5. So using that information, I would have the equation y equals negative 1x plus 5. All right, so let's say I wanted to write this in standard form. Well, I don't have any fractions in this one, so that's a little bit nicer. So the only thing left to do to get this to look like ax plus by equals c would be to get the x and y on the same side of the equation. All right, so I can do that by adding x to both sides. and then we get x plus y equals 5. So this is a very simple relationship. There are no coefficients in front of x and y, they're just ones, because here the 5 pounds is just a pure combination of some of the red, some of the gold. So some x and some y. So their sum is x plus y, and the sum of those two things would be 5. All right, so the problems you'll encounter in this section and for your homework often combine two of these types of equations. You'll have a more complicated one, maybe something describing a total cost in terms of two partial costs, a cost for two different items. And then a lot of times you'll have a simpler equation, and you don't want to overthink this one, but think about, do you know what the sum of the two variables is? All right, so let's look at a system of equations. So same thing, we're going to be looking at equations that have two variables, x and y, but we're going to be able to write two different equations and then solve using either elimination or substitution. Okay, so here's the first example of a system. A tour company in Chicago charges $38 for adults to take its famous architectural boat tour. The price for kids is $22. An evening cruise with 92 passengers brought in $3,160 in ticket fares. How many kids and how many adults took the cruise? Okay, so a lot of information. We have a lot of different units here. We have dollars. We have got 38 and 22. We have a number of passengers, 92, another dollar amount, and then we're supposed to find the number of kids and the number of adults. Right? So as always, step one is going to be to figure out what the variables should be. All right, so the variables will be the two things that you're asked to find. So I would focus on the question first and then go back for all of the other information. Right? So that last sentence instructs us to find the number of kids and the number of adults who took the cruise. Again, it doesn't say anything about one depending on the other. These two things are kind of equal in status, so we can let x and y be either of those two things. So I'll have x represent the number of kids, and then y represent the number of adults. Okay, so we have a couple other things going on. We've got the dollar amounts, so we can do something with that, and then we know that the total number of passengers is 92. Right? So if you can figure out the different units going on, for example, in this case we have people and money. Okay? That will often tell you what two equations you should write. Right? So we know a piece of information about people, how many people, and we know a piece of information about the total cost. Right? So an equation, just think of it as a sentence that tells you something about one of these things. A sentence that tells you about the people, or a sentence that tells you about the cost. Okay? So let's work with the number of people first. This is the easier one in this problem. We have a total of 92 passengers, and the passengers are composed of kids and adults, two types of passengers. So this is a very simple equation. This is like the last one we did. We know that the sum of the number of kids and the number of adults on the cruise would be 92. Okay, so that's our equation that represents passengers. Right? And then how about the cost? So let's see if we can take the shortcut this time. So let's go back to what we did with the peanuts and M&Ms equation. And we had that the total cost, 15, was composed of the money from two different things. The cost times the number of pounds of peanuts, and the cost times the number of pounds of M&Ms. So here we have a total cost of $3,160. Okay, so that's the total. So I'm going to have an equation that the total cost equals $3,160. And those ticket fares are coming from two different sources. They're coming from adult tickets and from kid tickets. So the income, the revenue from the adult tickets, it's $38 per adult. So I would have $38 times the number of adults, right? And the number of adults, I said, was Y. Right, so I'm actually going to slide this over. I'm going to put the Y second since this is standard form. Okay, and then I have some income from the kid tickets, $22 per kid ticket times the number of kids on the trip. All right, so if we had like 10 kids, then they would earn $22 times 10, or there would be $220 from those kids. And then the total cost is just the sum of those two things. All right, so that's the shortcut. If you wanted to, if you weren't sure how to get to that point, then you could still set up like an X and Y table the same way. Think about if there were no kids on this trip or on this tour, then how many adults attended. All right, so if it's $38 per adult and the total ticket fares were $31.60, then you could do $31.60 divided by 38, and that would tell you how many adults attended the tour. All right, and then this works out to be 83.1578947, etc. Right, it's not an even number. I'm sorry, it's not a whole number, so let's perhaps just leave this as a fraction. Okay, 3160 over 38. And then same thing, if we had 0 adults on the tour, then the number of kids would be 3160 divided by 22. And again, I don't think that's going to work out evenly. No, it doesn't. So let's just leave that as a fraction as well. Okay. And then from there, you could find the slope. It'll be a little bit ugly because of the fractions, but you can go from there, find the slope. We know the y-intercept, that's this first point. And then you could write an equation y equals mx plus b, and then get that in standard form. Okay, so we have one more thing to do. We found the variables, we wrote the equations, and we still need to actually answer the question, how many kids and how many adults? Right? So you may have heard this before, if you have two variables, two unknowns, then you need two equations to solve. Right? So we have enough information, we have two equations, so we need to solve this system using either elimination or substitution. So let me move to a new page and let's go ahead and solve this. All right. I'm going to do this by substitution. I'm making that choice because I see that x and y both have a coefficient of 1 in the first equation, so I think that's going to be a little bit easier. All right, so I would solve this for either x or y, and let's go with y. So I'm going to subtract y from both sides of the equation, and then get x equals 92 minus x. All right. Then next, 92 minus y. All right, then next, substitute that into the second equation in place of x. All right, so I'm going to replace x with 92 minus y. Now we have an equation in just one variable, just y, so we can solve for that. Okay, so distributing 92, or the 22, we have 22 times 92 is 2024, minus 22y plus 38y is 3160. We can combine like terms, so 38y minus 22y is 16y. Right? Subtract 2024 from both sides of the equation. And we get 16y is 1,136. And then divide both sides by 16. And y equals 71. Okay, then substitute that back into either equation to solve for x. So I think the first one looks easier. So I'm going to do x plus 71 is 92, and subtract 71 to find that x is 21. Okay? Now this is a word problem, so make sure you answer the question using specific units. So we need to know what x was and what y was. So x is the number of kids, y is the number of adults. All right, so your final answer would be 21 kids and 71 adults. Okay, and then don't forget that you can check this. All right, so you can substitute those values back into both equations and make sure they make both equations true. So the first one's pretty easy to see. Those two numbers do add up to 92, but check that they fit in the second equation to make that one true as well. All right, I have one more example, so let's try this one. Shrimp costs $10 per pound, and sea scallops cost $13 per pound. You want to spend all $100 that you have budgeted for a seafood extravaganza graduation party. So we're assuming that you have any money left at all at the end of college. It's probably going towards student loans. Let's be realistic, but suppose you do have $100 that you can waste on an expensive seafood party. Then in this case, we're going to buy a total of 8 pounds of seafood, and the question is to find how much shrimp and scallops you can buy. Okay, so again, start by focusing on the question. What are you trying to find? And then identify the variables. Okay, so we have x and y, and let's have x be shrimp, y be scallops. Let's be a little more specific than that. Go back for some units. Are we talking about the number of shrimp, the pounds of shrimp? And here we have pounds. Okay, so x is pounds of shrimp, and y can be pounds of scallops. Okay, so then let's write a couple of equations. So we have another clue. I talked about looking for units to tell you what equations to write. You could also look for restrictions or requirements. So we have two needs here. We have this need or requirement that we spend all $100, and we also have the requirement or the need to purchase 8 pounds of seafood. So those two things would also be clues to tell you which equations to write. Okay, so if we go with the money first, we want to spend $100 and have that be the total cost, right, or the total amount spent. So how are we going to spend that $100? Well, it's going to be split up between shrimp purchases and scallop purchases. Right? So some of the money is going towards shrimp. It's $10 per pound of shrimp. So that would be $10 times the number of pounds of shrimp, so that's x. And then we're adding to that, some of the money is going towards scallops. So it would be $13 per pound of scallops times the number of pounds of scallops. Okay, second requirement. We want a total of 8 pounds of seafood. Right? So we already have x and y are pounds, so this is the simpler of the two equations. We just want the sum of shrimp and scallops purchased, x plus y, to be equal to that total number of pounds, equal to 8 pounds. Okay? And then these two equations guarantee that we'll meet both requirements. We're spending all $100 on shrimp and scallops at each of their respective costs, and the sum of shrimp and scallops is 8 pounds. So same thing, let's take these two equations. X plus y is 8, and 10x plus 13y is 100. and let's solve to find x and y. Okay, so again, I think elimination would be easier here, but let's use substitution just to review that method. So let's say you want to eliminate the x's, then let's multiply the first equation by negative 10. Right, so that's going to give negative 10x minus 10y equals negative 80. Okay. Then adding those two equations, we would eliminate the x's, and then 13y minus 10y is 3y, and 100 minus 80 is 20, and then divide both sides by 3, and y is 20/3. Okay. You may also want to think about this as a mixed number. If you try to do a decimal, it's going to be a repeating one. And I want to make sure that we don't round answers here. Let's give exact answers. So if you divide that, you're going to see that this is 6.6666 repeating. That is 6 2/3. And you could also get to there by converting this into a mixed number. All right, so a reminder of how to do this. Okay, 20 divided by 3 is 6 point something, so we know it's at least 6. Okay, 6 is, now to go back from a mixed number to an improper fraction, you would do 6 times 3 plus the numerator to get 20. So 6 times 3 is 18, and then I'd have to add 2 to get 20. So this would be 6 2/3. Okay, to solve for x, I'm going to leave y as 20/3 for now. No, I think we can handle it. Let's do y as 6 2/3. All right, and I'm substituting back into the first equation. So then x would be 8 minus 6 2/3. All right, so 8 minus 6 would be 2, and then subtracting an additional 2/3 of a pound would leave me with 1 1/3 pounds. All right, so then the last step is to actually answer the question, use units. So x was the pounds of shrimp, so we should purchase 1 1/3 pounds of shrimp, and we should purchase 6 2/3 pounds of scallops. And there we have it. All right, so again, you can check, make sure that these two things add up to 8, and then also substitute these into the second cost equation and make sure that the total cost adds up to $100. All right, so there we have it. We've talked about writing single linear equations in standard form, ax plus by equals c, and then we've looked at solving systems of equations to solve for two variables.